Hey, this is quiz review for question one. Um, Working on that. So tomorrow in class, what we'll do is you're responsible for this type of problem. You're going to get a very similar problem with just some different numbers, but it's basically the same problem. So we're going to get you to be an expert in this problem, and then tomorrow in class we're going to get in small groups, and you will be working all together as a group, but your specialty will have been this problem. By all means, you're welcome to look at the other types of problems, but if you were assigned question one, this is the problem you should absolutely be able to do and explain to your classmates, because they're going to see that same type of problem, and you're going to be the expert that if they have any questions, they should use you as a first resort. A lot of times I find that students better learn when other students teach them. So that's what I'm hoping to get through from this one. Alright, so let's look at this problem. You have an 800 Newton roller skater traveling down a 10-degree ramp. So they're at the top of the ramp traveling down. The roller skate wheels exert a total friction force of 5 newtons. If it's traveling down the ramp, that has to be up the ramp. Separate air resistance, and the roller skater is applying their brake as they skate down the ramp. So we got to figure all those things out. The wheels, the air resistance, and a brake. The braking force is 74 newtons. We've got to determine the normal force acting on the skater and the overall acceleration. So, to figure that out, we first really have to draw. So let's try to set this up. Here's our ramp. It's 10 degrees. And we have an 800 Newton FG. Okay. So, some of the other forces we have are a 5 Newton friction force. We actually have 3 forces that we're going to have to draw up. A friction force of 5 newtons. A air friction force of 3 newtons. It's another FF though. Both of those are FFs of 3 newtons. And finally, getting a little hard to say, this one's a much bigger force. So it's a braking force, but it's really an applied force. You're the one pushing down. So that's 74 newtons. So you have 3 forces acting up. They're all trying to slow the skater down. The skater's traveling down the ramp because it says traveling down the ramp. Excuse me. We have to find the normal force. The normal force is going to do something like that. We have to figure that out. So when we have ramps, we've got to break our FG force. Everything else, we want that to be our positive y. We want to rotate our coordinate axis. So we've got to find our FGY, and if you look in your notes, FGY is FG times cosine of the angle, and FGX is FG sine of the angle. So in our case, our FG is 800, cosine of 10, and 800 sine of 10 for those two. 800 cosine of 10 is 787.85. And 800 sine of 10, to get the other part, you're just breaking apart the gravitational force, is FGX of 138.92 newtons. When you break that apart, you can make your new free body diagram. I'll do that down here. So we broke our gravitational force into an FGY of 787.85 newtons. And on a ramp, that's always going to equal the normal force. So we found the normal force, 787.85 newtons. And I'm going to combine the two friction forces just for ease, because they're the same. 5 newtons and 3 newtons to be 8 newtons. Plus I also have my applied force from the brakes of 74 newtons. When they're the same type of force, you can easily combine them. That's not a problem at all. And then my downward force, which is my FGX. My Y's always look like X's. FGX of 138.92 38.92. Alright, so we have to find the overall acceleration. We know that there's no vertical acceleration, so the only net force we have to deal with comes from our horizontal. So you want to do total up minus total down. Our total up is 74 plus 8, which is 82, minus our total down, 138.92. And that's going to give us a net force of 56.92, really a negative 6.92 newtons. That negative again means down the ramp. And we need to use that to find our acceleration. So our net force, negative 56.92 newtons down the ramp over mass gives us our acceleration. And the mass we don't specifically know, but we can calculate it. Because mass is weight over 9.8. And our weight is 800. 800 over 9.8 is going to give us our mass. So our mass of this roller skater is 81.63 kilograms. Simple division will give us our acceleration, 56.92 over 81.63, negative 0.697, or 0.70, doesn't matter. Meters per second squared. That negative means down the ramp, DTR. There you go. So hopefully this type of problem you should be able to explain to your classmates. Break apart FG. It's always the first step in a ramp problem, into its sine and cosine, FGY, FGX. Use that information with the rotated coordinate axis to find our net force. The only net force we care about on ramps is the horizontal, because the vertical will cancel. Use that along with the mass to find acceleration. In class tomorrow you might get one that has an extra upward force, or maybe one less upward force, but it'll be a very similar question. So if you understand this, you should be all set for tomorrow. All right, perfect. Thank you, and good job.